right, so we are in AP Calculus. Today's date is Wednesday, January 15th, 2020. 1:15:20. This did not come from an AP test. So if you try to look up this problem online, it will come up in like probably a textbook, I would guess. I'm still going to make it out of 9 points. So we have a particle moving, we have velocity, starts at the origin, so that's at 0, 0. We need to find the acceleration, and we know that in order to find just acceleration, I'm going to find the derivative of velocity. So acceleration is equal to the derivative here of velocity. And if I take the derivative of velocity, that's equal to just 2. So my final answer, I guess I can rewrite it again. A of t is equal to 2. And if you have that, some sort of saying that acceleration is 2, give yourself 1 point plus 1. And A is just out of 1 points. Part B. Find all values where the particle is at rest. So the definition that you need to know is what does it mean to be at rest? And the definition of at rest, you guys will shout, is velocity is 0. Yes. So at rest is velocity equal to 0. Just one of those flashcard type of terms we need to know. So we set velocity equal to 0, right? So if there's velocity, I'm going to set this function equal to 0. So I'm going to say this 2t minus 4, I'm going to set that equal to 0. Add 4 to both sides to get 2t is equal to 4. Divide both sides by 2, t is equal to 2. All right, so I can actually type out the answer to make sure that the explanation is very clear. I can say that the particle is at rest at t is equal to 2, and why? You have to explain your answer. So I'm going to say because the velocity is equal to 0.
Is it also at rest at time equals 0 because it states that at time equals 0 the particle is at the origin?
So you don't know, you do know its location, but you don't know if it's at rest. Yeah, so that's a good distinction to make. You don't know the v value. In fact, if you check the v value at 0, you'll figure out that the velocity is actually negative 4. Yeah, so in order to get your points here, you can get 2 points. You need 1 point to say time is equal to 2 somewhere, and 1 point for the explanation v is equal to 0.
So this one's out of 2?
Out of 2 points, yeah, for B. For part C, all right, farthest to the left. So that's kind of like the minimum question. That's where, so think of a minimum. I'll put that in quotes. The minimum is where velocity is smallest. So I'm saying smallest v. Smallest v of t. Or you can think of this as one of the things that you need to know in terms of its definition to kind of help you with a shortcut is what? F prime. What's the definition of F min? F prime from, yeah, F prime goes from a negative to a positive. That will help you out. Kind of the shortcut that Arrow is using. So let's go ahead and make a table. Whenever you're doing a minimum or a maximum problem, 100% of the time, you need to make a table. So there's a line. What just happened? There's a line. There's a line. If I scroll up, down, does it fix it? Okay. That's really weird that happens. Okay, so we need values of t. I need to do start plus change, and that will equal my end. And maybe you don't like the word end. Maybe you want to think of this as position. Either way, that's fine. Okay, so you always need to check your start and end. So our start and end interval, we have, it starts at the origin. That's going to help with this position. Okay, time is equal to 0 between 0 and 4. That's what I'm really looking for. So 0 and 4 obviously need to be in here. And we also need to find any time that you might have a critical value. So this thing, make a note to yourself, the middle values here are always your CVs. You have to check, I mean, you don't have to check all of them. Specifically, you have to check the ones that go from a negative to a positive. That's the shortcut for the CVs. If you just find all CVs, then you might be doing too much work, but at least you'll have the answer. So start and end, and then all the CVs. So where does it equal 0? No, hey, we just did that in part B. It equals 0 when it's at rest at t is equal to 2. So this is t is equal to 2. Now we have all possible values. All right, the start position is at the origin, so that means My start position is 0, so I'm going to say 0, 0, 0 for my start position. And then my change, this is going to be the integral from 0 to 0. I start at time equals 0 because it told me that in the problem at time is equal to 0 is when I'm at the origin. So that's why that bottom bound is 0. So this is going to be the integral from 0 to this number 2. And this is going to be plus the integral from 0 to that time 4. And all of these are going to be velocity. I'm going to kind of abbreviate here because it doesn't really matter that you're formal in your explanation. If you want to say v of t dt, that is a little bit more formal. And then you need to figure out what's going on. So 0 plus, and then you can always think of integral from the same bound to the same bound is 0. So 0 plus 0 is 0 for that end value. I guess I can do that in different colors, 0. The integral from 0 to 2, well, what's happening there? I have to take the integral of velocity. We might as well do that down here. There is another way to do this graphically, but I'm going to do this algebraically. So the integral of v of t, not the definite integral, just like the antiderivative, dt, is equal to, well, what do we have up here? So 2t, that's going to go up a power, so it's going to be 2t goes up squared, and then divide down by 2. And then I have to take the antiderivative of negative 4, so minus 4t. And then don't forget your plus c. And you know what your c is. Your constant of integration is always your starting condition. Well, where did we start? 0. So c is actually 0. So our new equation that we can start plugging in is when we plug in 2, we can plug in 2 into the value of t. And notice that, Command Shift C. If I cancel out those, I'm really left with this nice equation, t squared minus 4t. And I can plug in these t values and have a shortcut for what's happening with this integral. And in fact, it's a shortcut for the entire problem because 0 is the value of c. So when I plug in 2, that's going to be 4 minus 8, which is negative 4. When I plug in 4, 4 squared is 16, minus 16, oh, that's 0. 16 minus 16 is 0. So where is it, the n value? The smallest, the minimum. The minimum is at 4. And you have to find the time at which it's farthest to the left. So my final answer, all in words that you should be typing every single time, or writing, I guess, if you're not typing. The particle is farthest to the left at t equals 2 with position negative 4. Or at position negative 4. It probably makes more sense. If you have the position and the time, you can't go wrong because sometimes they ask for the position, sometimes they ask for the time. All right, so in order to score yourself, since this is an AP question, I'm going to make up some things. Let's say you get a point for getting the time, right? Time is equal to 2. So plus 1 if you had time is equal to 2. You get 1 point for having some sort of table-like structure to at least explain that, hey, I'm doing some math and I've eliminated these values and I've chosen 2 from those values. And I need to do 1 point. Let's just say if you somehow had 0 in your answer, you included the initial condition. All of those zeros. Question, Gio.
So I had a table.
Have a table?
Yeah.
Okay, so is it a complete table? Does it have 0, 2, and 4 in it?
It has 0, 2, 4, but it doesn't have the zeros on the sides.
Okay, so you get a point for the table, but you don't get a point for having the zeros for the start condition. You have to somehow say that the start condition is 0.
Too?
Yeah.
That's great.
So that's going to be out of 3 points. And again, it feels weird for grading this one because it's not quite an AP question. And then finally, part D.
This is going to have to be worth 3 points if you want it to be at 9.
Ah, shoot.
Just so you know.
Man, are there any way we can assign points higher? Okay, it's not going to be out of 9. I lied to you guys. I'm sorry. There's no way.
On problem 1 for the equations in?
Okay, yeah, we can do that. We can say 1 point if you somehow said v prime. Let's do that.
Yeah.
Plus 1 if you said v prime, so now this is going to be out of 2. Did you not do that, Gio? It's something that you should be doing, so we've added a point. Now this needs to be 2
I didn't
points.
get the answer right.
Okay, let's do like 2 points. 1 for the bounds and 1 for the absolute value or something. I don't know.
Okay.
So the actual answer here is integral between 0 and 2 of the absolute value of vt and absolute value dt. All right, so we'll say 1 point if you had the absolute value of all that stuff. This is called the integrand. And then 1 point if you got the bounds correct. So that's going to be out of 2. Hey, we got it out of 9 points. Good job, guys. Out of 9. Now I'm not a liar. I just had to be helped out a little bit. All right, how many points did you get? Hold up your fingers. 7. Oh my God. 9, 1, and 3.
This
Okay.
isn't 9, this is 8. Both of my thumbs are down.
I assume one of them was up. All right, so what did we learn, though? Starting with Arrow. What did you learn, Arrow?
That one where I like kind of drew the table, but not that much. Probably should have finished the table instead of doing the shortcut just because of the explanation.
Okay, just finish the table.
Yeah.
Any other things?
Now I have to read the questions carefully because I've misread the last one.
Ah.
Same.
Yeah.
Same.
Okay.
What was the misreading? Were you
I thought the bounds were different.
Oh, okay,
I
interesting.
did the average velocity.
Oh, average velocity. Interesting. Okay. Did you get the average velocity equation correct? Did you do the integral divided by 2 minus 0? Hey, good job. So you got the definition right. It's just the reading thing. What else did you learn, Gio?
Yeah. That's it.
You had the table 100% correct. You
Kinda.
kind of. What did you learn about the table then?
I didn't do the star condition.
Ah, the star condition. Yes, always list the star condition. It's almost a free point every single time. Remember how last unit in unit, 2 units ago. No, yeah, last unit. In unit 6, you got a point for just writing plus C when you did the integral. The freebie, that's your freebie point. If you include the start position, like, it's only like 60% of the time
What
instead
if
of
you
90% of the
just
time.
write 0? Like you already know you got 2 points and you just write a giant 0 in that space.
That's fine, yeah. That makes sense. It's kind of a fun little way of making that a giant 0 right there, but whatever. Anything else that you learned, Gio?
I mean, like, you don't do any of the rest of that problem. Just write a 0.
Oh, no, yeah, don't do that.
Yeah, 0, 0 for sure.
Any other things that you learned, Gio?
No.
All right, and then Sega, what'd you learn?
You need to make a table and it's farthest to the left or farthest to the right.
Good.
Position.
Perfect. Yeah, other things that you learned?
When it's traveled, you have to have the absolute value.
Distance traveled, absolute value. Yeah, good. Other things?
That was it.
All right, cool. And Claire, what'd you learn?
That the point particles of the word in the thing it said it's not talking about velocity.
Oh.
Because I put that it was at 0 too.
Oh, okay. Yeah, it's a good thing to learn. All right, so that is 7.5. Then you guys have 10 minutes now with a calculator to do 7.6. All right, so self-check. 7.6. We have another particle. It's almost the same types of questions. We need to write an expression for the acceleration of the particle. So that don't even need a calculator yet. So you need to do 2 things. You need to first say that the acceleration, a of t, is by definition the derivative of velocity, v prime of t. And then you actually need to do that by hand, right? So the derivative of velocity, ooh, careful here. This is going to be product rule. It's 1 and 2. So product rule is going to be 1 d2 plus 2 d1, and then I can take the derivative of negative t, which is negative 1. So 1 d2, maybe I should make that a different color to make it pop out more. So 1 is t. d2, the natural log of t, when I take the derivative, is 1 over t, plus 2d1. So 2 is natural log of t, and the derivative of 1 is just 1. And then don't forget to take the derivative of minus t, which is now minus 1. All right, let's go ahead and simplify this. So t divided by t is just 1. So this is to 1, and then I'm going to subtract 1, so those cancel each other out. So my answer is purely natural log of t.
Is there a plus C?
Natural log of... Since I'm taking the derivative, I'm not going backwards, so I don't have to do that. Natural log
Derivative thing that you need. Oh, it's dinner. Okay.
t, yeah. So yeah, don't forget your dinner. And so times 1, right, if I was doing that. Yeah, so there it is, natural log of t. If you somehow... Yay, thank you. Thank you. If you somehow said that you need to take the derivative of velocity, that's 1 point. If you somehow said it's natural log of t, that's 1 point.
So is that at 2 points?
This one's out of 2 points, yes.
Is this one an actual?
It is not. No, this is another one pulled from a textbook, but I redid the points just like we did on the last problem to make it sure that's out of 9, so I can promise that, and if I messed up, then you guys can help me add. Adding is hard. Counting is hard. For what values of t is the particle moving to the right? What is the definition of moving to the right? That's where velocity is
Greater than 0.
greater than 0. So I need to find where it's greater than 0, and I have a calculator this time. So I plug in velocity. There it is. Make sure that my window is correct, between 0 and 4. I get the graph. I hit zoom 0. So we have our graph. I need to figure out where it's moving to the right. So it's wherever it's to the right, it's this positive area over here. So I need to find this intersection, this 0. So second trace, 0, hit 2. I'm going to guess, yeah, right bound 2, or sorry, left bound 2, right bound 4, I don't know. Guess 3, enter. You can always hit left and right arrows, of course, or clairs as we call them. The answer, is E, 2.718281828. So that number's E. I'll write it down in 2 different forms. So I know that my, maybe I should paste this value in here. I should paste this graph in here. This 0 is 2.71828. Now I'll have it my key for later. All right, so now I'm going to say that this is where it moves to the right, right there. So that happens on what interval? And I'm just going to type up my answer to make it go a little bit faster. Particle is moving to the right on this interval from 2.718 less than t is less than or equal to 4. I can't write less than or equal to in the text editor. Less than or equal to, I'll just add the line later. Less than or equal to 4. Why equal to 4? Because it's still moving at 4, and 4 is included in that interval. They're not going to take off a point if you forgot the equal to sign. Or you can just do 2.718 to 4 and do a square bracket.
Is it wrong if I wrote the particles moving to the right at 2.7?
That is incorrect. Yeah, you need to do a range. So for what values? This is values plural, so you do have to have a range here.
What if I didn't do a square bracket?
If you didn't do a square bracket, you still get a point. They don't care about brackets on the AP test. They don't distinguish between those two. So, and then you need to have a reason. I forgot to explain my answer. So come back here, Mr. Sindel, explain your answer. And it's because velocity is greater than 0. Yay, now I have the answer. So how do you score yourself? Out of points we have 1 for the interval, so +1. And 1 for the rationale, that's a bad one, +1, there it is. And 1 because you said V is greater than 0. And I'll also make the note that this
Is that
two,
the same? Oh, yeah, never mind. Yeah.
that's the same thing as E, which is not Euler's constant. Euler's constant is actually something else. Euler did so much that he has like a plethora of theorems and constants, so I'm just going to say
So
that's
is
E.
that 2?
That was out of 2, yes. Out of 2. Find the time t when it's farthest to the left. So farthest to the left, that means I'm making a table, because farthest to the left, that's kind of like the minimum. So let's go ahead and draw a table. Yoink. I don't need that big of a table. Is it gonna mess it up again? Let's see. Hey, okay, nothing bad happened. We need values of t. We need to do a start plus change is equal to the end, or the position. Okay, so we need to do the beginning and end. So 0 and 4 need to be times in that table. So 0 and 4. And then I need to put any critical values in here. Again, make a note to yourself. The values that go in between here are the CVs. CVs are that middle area. So critical values, there's only one. Look at that graph. The graph only has a critical value here at 2.718. So I'm going to write down 2.718, or if you're super cool, you can put E. So our start value, let's come up here to the original problem. Our start value is time is 0, and the start position is 6. So our integral is going to go from 0 to something, and our start is 666. So start is 6, 6, and 6. Our integral will always go from 0 to something, integral from 0 to something, integral from 0 to something. This is 0 to 0. This is 0 to 2.718. This is 0 to 4 of velocity, of velocity, of velocity. Then we need to calculate those things. In fact, you don't need to do all of them, but let's go ahead and calculate them all anyway. So I'm not going to use my graph because it frequently gets you errors on the newer calculators, and it's faster this way anyway. So math 9, the integral of my vars right, enter, my y1 function with respect to x, from, 0 to 0 we don't need to do. I'm going to do 0 to 2.718, or if I'm fancy, 0 to e. Do they have, yeah, so second division, e. And go calculator, go calculator. negative 1.847. And I'm adding that to 6, so I can now just say plus 6. And I get 4.153. So 4.153. I could have done this one. The zeros for the start and end interval makes it so it's gone, and then 6 plus 0 is just 6. Then let's do this integral. So I'm going to do, okay, you want to see a cool trick? Instead of 2 steps, I'm going to do it in 1 step. Ready? 6 plus math 9. So I'm doing 6 plus the integral, right? Oh, so fancy. So 6 plus var is right, enter, enter. Y1 with respect to x, so comma x from 0, comma 4. And my answer is, it should be like 5.090, I think. Is that what everyone else got? Go! Calculator, it's loading. You can see the scrolling bar. 5.090. Woohoo! 5.090. We're looking for the minimum value. What's the smallest value? Oh, there it is. The smallest value is 4.153. There it is. So I'll go ahead and just leave that circled. Why not? Go ahead and write out your answer. Practice writing out your answer every single time. My answer. The particle is farthest to the left. At t is equal to 2.718, which is e, right? At position 4.153. And you don't need, okay, explain your answer. The table explains your answer for you. So go ahead, and in terms of scoring, if you said it's farthest to left at 2.718, give yourself plus 1. If you had a table, give yourself plus 1. That's your explanation. When it says explain your answer, your table is your explanation. And if you have a start condition, start condition will give yourself plus 1. Sometimes people say, oh, give yourself 1 point if you considered 2.718. I'm going to do it for a start condition. You can flip-flop.
If the start condition is wrong, you get a point, right?
You don't get a point if you got the start condition incorrect. All right, so that one was out of 3 points.
I
So
did 2.7, is that the same as 2.718?
say again?
Because I put 2.7, is that the same as 2.
No, you have to do 2.718. Yeah, always round to 3 decimal places. Is that the mistake? It was just a rounding error? Okay, darn. Well, now we know it for next time. And then part D, find the total distance traveled. So we've done this problem. In the last one, we just had to set it up. Now we have to solve it. So total distance traveled. I guess I can underline the travel too. That is the integral from 0 to 4. So 0 to 4. I can really put it on the bottom and top instead of out to the right. 0 to 4 of the absolute value of velocity and absolute value dt. Okay, so that is going to be approximated by, we can do math 9. Wait, didn't we just do that? No, we didn't do absolute value. So math 9, and then I do math right, enter. The absolute value of var is right, enter, enter. Absolute value of y1, end the parenthesis there, with respect to x from 0 to 4. And that's going to take a while because absolute values just are insanely slow.
On this one, do you consider the start condition or no?
You don't need it because total distance traveled, you don't care about where you started. Like if I started at 100, but I moved 2 inches, the total distance travel is 2 inches.
Okay, yeah.
Exactly, yeah. So 2.785. 2.785. 2.785. How do you score yourself? 1 point if you wrote the absolute value integral, all of this integral stuff correct. And 1 point if you got the answer correct. So that's out of 2. Did I add up to 9? Did I check? 5, 6, 7, 8, 9. Woohoo! Out of 9 points. Geo, try to trick me. Go ahead and score yourself.
Sorry about that.
Hold up fingers. How many out of 9 did you get? Don't trick me with 8. Do 8 this way, this. Or you can do it in binary. No, don't do binary. That's flipping me off. Okay. 7. Good job. Oh my God. 8. 3. Yes. 3. We're hitting our goals. All right. What did we learn? And hopefully we learned something and not nothing. But let's see. What did we learn, Arrow?
So the last problem on the other side, I learned to read carefully. And this
Well, what did you
one,
learn on this side?
I have to learn to write carefully.
Write carefully.
Yeah.
What was the mistake?
On part B, I wrote 0 to 2.718.
Oh no, you did
Like,
to the
I
left.
knew.
Oh no.
I just wasn't paying attention.
Okay.
And then I got the take the integral by hand, or no, it was derivative by hand on part A.
Oh yeah, product rule. Yeah, that popping out was scary. What'd you learn, Claire? Product rule. Yeah, product rule. Whenever you see 2 variables, be scared. Be scared of product rule. Well, maybe not be scared is the right rule. Just know that you have to use product rule is probably the proper way of saying that. Sega, what'd you learn? Product rule.
And go 3 decimal places after the decimal.
Yeah, okay. Always around 3 decimal places. Other things? Okay. And then Gia, what'd you learn?
I learned prior rule. So that was me up.
Okay.
Write the right start condition.
Okay. Yeah. What did you write instead of 6?
I put 0.
Ah, darn. Okay. Yeah. And then other things that you learned?
That's it.
Cool. Well, that concludes our self checks.